Good afternoon. I'm speaking on AppSync today. I've done a bit of this, so hopefully you guys get something out of the presentation. Has anybody here actually used AppSync? Okay. My presentations, by the way, I don't like to lecture, so if you guys have, even though the big voice in the room, if you guys have questions, just stop me and ask them as we go. I'd rather have a discussion than sort of a professorial teaching moment. So, building web applications traditionally, at least I find it to be somewhat of a grind. In fact, I think it kind of sucks. So the steps that you normally take if you guys have built a web application before is you try to define the data model that your UI is going to need. You try to define that API interface, and the reason I say try is because you never really succeed, not the first time around. You build them, if you're good, you build a mock interface so that your front-end guys can start working. You start building out the UI and the back end, then you realize you screwed it all up, and you do it over again, and that repetitive cycle takes quite a while because there's generally two different teams that are doing it. And building web services, while it's way faster than some other things, is still kind of a slow endeavor, right? You gotta go build the code, test the code, deploy the code, etc. Turning around on a dime is very difficult. And if the web service doesn't give you exactly what you need as an application developer on the front end, it's up to you to filter the data and manage paging, subscriptions, all that sort of thing. So there are certain hacks that mitigate this pain, and I've done almost all of these. So one of them is you can build one restful CRUD service that basically serves as the CRUD service for all of your data. But the problem with that is that that's kind of a big thing that is relatively abstract and not very specified. You can use Swagger to generate your back-end API integrations. I've done this a bunch, but that really doesn't solve your web services issue. That just solves your interface to your web services issue. You can add more parameters to your RESTful service calls. So the ones that used to serve you, now that don't serve you completely, we just start tacking parameters on the end of that list, so to speak, to make the RESTful services work for my new front-end requirements. But that ends up with kind of a munge, right? You're almost getting back to that generic CRUD sort of access. I could build one super generic API, think star KWArgs, where I pass in basically a generic JSON, and I have a director in the back end that tries to figure out what the heck the front end actually wanted to do and give back the data. Or you can day drink so that you don't care that your job has become a grind, building web applications which were supposed to be super fast and really easy. So there has to be a better way, and there actually is, and it's called GraphQL. So Facebook built GraphQL to solve many of these problems, specifically some of the turnaround time problems, and the desire for front-end application developers to be able to specify what they wanted from the back end, sort of in a dynamic way. They built it in 2012. In fact, all your Facebook apps, if you have Facebook on your phone, run off of it. They released it to the wild in 2015. And these are quotes basically from the GraphQL organization page. It provides a complete and understandable description of your API, which we'll get into in a second, and gives clients the power, this is pretty interesting, to ask for exactly what you want and what you need on the front end, instead of just taking what the web service gives you as defined by some sort of web service developer. However, there's one big caveat to running GraphQL in most implementations, and that's you have to run a GraphQL cluster that serves as the interpreter between the GraphQL language and whatever back-end data stores that you're actually accessing, because you got to store the data somewhere, right? GraphQL doesn't define that. So AWS has answered this with something called AppSync. So AppSync is we'll get into the details in a second, but it's basically a fully serverless GraphQL implementation that allows you to build very rapidly APIs, quote unquote, for your front-end applications, and allows you to modify those very, very quickly. And this is actually the AWS diagram. So you execute an operation against GraphQL. You can support queries, mutations, and actually sign up for subscriptions to watch things that change. The GraphQL engine translates that query or the mutation request into a back-end access to DynamoDB or Aurora or Lambda or a variety of other things. So, some of the features. It's completely serverless. You don't have to stand up a server. You don't have to specify to AWS how many servers that you want. You don't have to figure out how many clients you're going to have that run against it. AWS completely manages this for you and scales the GraphQL endpoint to your requirements. It integrates on the back end out of the box with DynamoDB. You can actually auto-generate CRUD-style API from an existing DynamoDB table. It integrates with Lambda, which basically means you can do whatever you want. So you can send in, and I do, things that normally people don't use for GraphQL. Like I have one for another customer that starts a workflow in step functions. You can integrate with Aurora. How many people here are familiar with Aurora? Okay. Yeah, it integrates dynamically with Aurora, giving you access to a back-end relational style database without actually having to write code. Well, without having to write traditional code. It integrates with Elasticsearch. So if you're using Elasticsearch to deliver search results back to your front end, you can do that directly through here. And finally, it'll integrate with any HTTP or HTTP endpoint that you already have. So if you have some legacy web services and you want to start using this, but you don't want to replace those, you can layer this proxy on top of them. So for all new development, you can use this proxy instead of that and then gradually replace those legacy RESTful web services if you wish. And finally, it fully incorporates security. So you can tie this in with API key basis security or with Cognito JOTS, or you can do your own. And the security is not just access to the API, but you can also go very granular as to what people can see within the data models that you're returning. So what are the components of AppSync? Because the underlying system is somewhat complex, and learning it will make your life a lot easier when you start to implement it, especially when you stop pushing magic buttons on the console and you start trying to DevOps this infrastructure as code. So the first part is the endpoint, which should be pretty obvious to anybody that does RESTful web services. This is the API location that you attach to from an existing client. Then there's the schema. This is probably one of the most important pieces, and this is the one that is GraphQL standard. It consists of types. You can define your own structures. They kind of look like classes, but they're really more like structures. And then there's specialized types, which are queries, do exactly what you think they do. They go off and get data for you. And you can manage pagination within those queries too. So if you have 1 million results to return, you can pretty easily make it to where you return 100 at a time based upon what the client requests. Mutations, which are what you would expect, they do changes to your back end. So if you were to put a new person object as an example, that would, depending upon how you wrote your back end, insert that into DynamoDB or update a row in Aurora. Or if you're using an HTTPS legacy function, call that legacy function with a put. And then subscriptions. Subscriptions work off of WebSockets. And when you subscribe to something, you will get updates that occur from all the other clients on a push basis from the server itself. So your RESTful web application or your mobile application can sit there and listen to the subscription for, let's say, I'm showing a list of customers. When somebody else updates that customer with the new address, it will just simply get pushed directly to my phone. And I will be able to see it without my application having to go off and run a polling query to find that new information. So that's the schema. Then there's data sources. Data sources are the integration in AWS between your actual data syncs, DynamoDB, HTTPS, Lambda, and the front-end schema. So this is how basically AppSync connects these two, and they have to be created. So just having a DynamoDB table is not sufficient. You have to wrap that table in an AWS data source, AppSync data source, to make it available to AppSync. But once you do that, it's available across all your schemas. So it's not So one thing that you need to understand about AppSync as we go through is that these components are loosely coupled together. So the schema is not tightly coupled to data sources. In fact, it's not really coupled at all until you give the name of the data source, which we'll talk about in a second, with the resolver. And the resolvers are not tightly coupled to the schema either. They're coupled by a loose coupling by name. So you can start to combine these things in a very dynamic fashion across schemas or across data sources without having to recreate some of the stuff that you put in there once. The next component, which is a new one for AppSync, is called functions, and we'll talk about those in a second. Functions are back-end processes that run inside of AppSync that do not actually return results to the client at all. They are reusable code that, for instance, let's say I had a CRM application and I wanted to look up a customer and then use that looked up customer and subsequent queries for perhaps where into the address table if I was using a tabular table-based thing like Aurora. I would write a function that looked up the customer, and then I would use that information in a next function that looked up the address and the Aurora tables, and then I would return the address from what we're going to talk about next, which is our resolvers. Resolvers are the glue that tie the queries, mutations, and subscriptions in your schema to the data sources and the back end. And we'll look at resolvers in a second. Resolvers are written in Velocity template language, and they allow you to very, very quickly manipulate what is a JSON input from AppSync into what you're going to be doing on the back end for getting your data or putting your data. There's two types. There's a standard resolver, which accesses one data source, and then there's a pipeline resolver, which takes functions and can access multiple data sources as it moves through its pipeline. So what do these look like? This is a schema. Normally it would have been all linear, but I ran out of room. You always have to have per GraphQL the schema declaration. I'm not exactly sure why. It seems kind of redundant, but you do. And here we define that we have queries, which a type query, which is query, and a type mutation, which is mutation. You can change those names. I wouldn't recommend it. You'll confuse everybody. Lower down, you'll see I have defined a query, which is get post, and I pass in an ID, and it returns a type of post. Remember, I said schemas have types too. You can define any type you want. And then I have a mutation, which is add post, which takes, by the way, the bangs on the end mean that they're required, which takes an ID, author string, or author title, content, and URL. Everything's required. And that mutation is going to return a post, which is, because of the bang at the end, says it's required. And then I have a type, which is post, basically defining your data structure that I use in these other calls. Now remember, this doesn't do anything. You can put the schema out there right now in your own AppSync. You can go ahead and create an AppSync API, drop the schema in. It's not going to do anything because there's nothing tied to the back end. Remember, every tie is loose. So we're going to have to tie a resolver to this. Resolvers consist of request and response templates. The request template is exactly what you think it is. It takes the incoming request and applies that to a back-end data source. And then what comes back from there is passed through the response template. Now, response templates are generally pretty limited. They can be complex, but most people do what we'll see here. So on the left, you see the request template. So we're basically, this is a DynamoDB query, which is an operation put item. So we're putting an item here. We pass in the key because this is conforming to what DynamoDB needs. You always need to put a key in, right? Just like if you use DynamoDB from Python or something, you have to specify the key when you do a put, and then the rest of the attribute values that are going to go in there. What I want to return is just a JSON, basically a JSON transformation of the context that comes back in the result from that put, which in this particular case is going to be the actual object. Most of your response templates will look like that on the right, which is util.choJSON, et cetera, et cetera. Functions and pipeline resolvers, we've already talked about these a little bit. Functions are specialized resolvers that can only be called from other resolvers. They allow you to build custom reusable code inside of your AppSync implementation and then chain those together in pipeline resolvers. Pipeline resolvers look exactly like regular standard resolvers, except their front and back templates are called, let me see if I think they're called like before and after, and then you specify which functions in the order that they run internally. This really can be used to provide some fairly advanced stuff just from VTL. Like I said, if you want to access 2 different tables, or perhaps you have a DynamoDB and you need to take information out of that DynamoDB table and go into an Aurora database to get the actual result. You can do all of that with functions as you move through the pipeline. And then finally, how do you work with this on the front end? Well, that's actually pretty simple. There are other GraphQL libraries out there, but AWS provides you with a really nice one called Amplify. It's a React.js or Vue.js, and I think you can use it in Angular, but I never have. That gives you a GraphQL client that you can query pretty much as simply as this. And it manages all your state for you. It manages caching of that information. If you do subscriptions, it'll watch the subscription for you. Makes it very, very simple to access your backend AppSync library. And if you don't want to use that, you can use one of the other variety of GraphQL front-end libraries that exist. So, yeah. I think it probably only works with AWS. It's pretty AWS specific from a number of other areas. I've never tried to actually go to another GraphQL implementation. So all of that's awesome, but how do I manage this from a DevOps and architecture perspective? Because I don't want to, we'll talk about several ways to do that. One, you can actually use Amplify. Amplify is not just a client library, but it's also a console that you can use as a developer to create a whole bunch of stuff. The problem with using Amplify to do that is it's a big magic button. So think about, have you guys ever worked with Hibernate in Java, where people design their Java classes and then they run it through Hibernate and you get some sort of goofy schema that comes out the back end? Amplify will do similar things for you. You kind of define your schema and then you say go, and it'll actually create DynamoDB tables for you, in addition to all the other little pieces that I just talked about. The problem with that is it's completely not repeatable, right? So if you have dev, production, and stage environments, you would have to go push the magic button 3 times to get that replicated across those and hope that your inputs were the same in each one of those 3. So that's really great from a perspective of I want to build something very quickly and test it, but it's not too great operationally. The second way to do it is you can use an AWS provisioning toolkit. So this would be predominantly CloudFormation or Terraform. And you can build all of those pieces that I talked about with that toolkit. The challenge that I have with that is that puts code deployment into your provisioning toolkit, because your schemas and your resolvers really are code. I don't like to do that myself, because that reduces the ability to do a true CI/CD pipeline throughout your organization, because now you have to run Terraform or you have to run CloudFormation to do another code deploy. Whereas, with the traditional kind of continuous deployment model, when the code is checked into an appropriate branch, it gets deployed to an appropriate environment. You can use standard CI/CD, so you could put all of the stuff into a standard CI/CD process using AWS CLI and basically hand code all of that. But once again, I have a challenge with that, because that's putting the construction of infrastructure into your CI/CD pipeline, which is a development sort of construct. So I actually use number 4, which is a combination of 2 and 3 to get this done. And how I do that is I use provisioning to create the GraphQL endpoints and the data sources. This is a great use for CloudFormation or Terraform because I am actually provisioning an API endpoint when I create a GraphQL API. And all my data sources are based upon other resources that I've created in Terraform or CloudFormation, like DynamoDB tables or Aurora serverless implementations or Lambda functions, etc. And then I create a code repository for the schema, the functions, and the resolvers. So generally it's a code repository for each schema, each function, and each resolver. And I've written some basically Python helper classes. You don't have to run Python. This isn't Python code, but I just like to write Python. I wrote some Python helper applications that will upload and manage those appropriately to the GraphQL schema that you specify. What this allows you to do from a DevOps and a developer perspective is it puts the power of the interface to your backend back in the hands of your developers. So as a front-end developer, if the schema is not just exactly what I want, I can go in and add another query line. And then I can check that in, and in Dev, literally in just a couple of minutes, I can go from this is my desire to it's actually running an AppSync, and I can make calls to it. Similarly, if I have a particular, say I have an Aurora table and it has 15 fields, and the original developer of my schema decided they were only going to expose 10, but I need that 11th exposed. I can go in very, very quickly and add that, check it in, and with CI/CD, have that appear in my development environment so I can continue working literally within minutes. That's the sort of turnaround that you really can't do ever with web services. In a web services environment, I would have to probably pick up the phone, unless I'm a full stack developer, which I'm not one of those, and I haven't met too many. But I have to pick up the phone or put in a ticket, get the actual web service developer to change the web service, get it to go through the deployment cycle to be available, make sure I don't break anything else as I do that, and then it's available 2 or 3 days later after I needed it, which really, really slows me down and frankly slows down the company. So I know I talk fast. That's AppSync. There's not much more to it. Questions? Go ahead.
So does every developer get their own deployment of AppSync? Is there a dev environment?
You could if you wanted to. I don't do that. I just do a generalized deployment.
How is it priced?
What?
How is it priced?
Free.
You pay for all the underlying.
Of course, yes, yes. You pay for all the data transfer and all the underlying resources, but AppSync itself doesn't cost you a thing. Other questions? Okay, go.
What kind of adoption have you seen for AppSync, say, at least in Birmingham?
Well, the projects that I work on, obviously it gets adopted pretty soon. I haven't taken a poll across everybody else. I do know that front-end guys love this thing because the queries are simple. You get to specify, so if let's back to that Aurora example, let's say I have 15 things, but really only 2 of them I care about for this particular part of my application. That's all I really want. I don't want the other 15. I don't want to transfer them. I don't want to deal with them when they arrive. Couldn't care less. With AppSync, I can ask for just those 2 things that I want out of those records. And AppSync handles it completely for me. So I get back the data I need when I need it. All the front end, I'm not a front end guy, but all the front end guys that I talk to love running against this as compared to trying to integrate with standardized web services. Additionally, you don't have to, if you use Amplify, you don't have to put Redux in on the front end any longer. And Redux is kind of a pain in the butt, especially if you screw it up badly. It causes some really weird things to occur. With AppSync, just ask for the data that you need when you need it, post the data that you want to mutate when you mutate it, and let the backend manage that for you, plus obviously the GraphQL front-end library.
So it also seems to be a better use case for, say, internal tools than somebody consuming your services, because to consume your services or to consume your data, you would have to know the data model or something like that, right?
Yeah, I mean, you could post it. If I was doing server to server, I'm not sure I would really use AppSync. I think I'd use a standard RESTful model. But I want a much slower rate of change if I'm doing that anyhow. You could let somebody access AppSync and lock it down with like an API key because it does support that. But yeah, you'd have to publish your schema to them. So I think I would do AppSync if I was letting people build third-party user interfaces on top of my stuff. It's for a server-to-server sort of communication, it's not nearly as intuitive. You have to find a GraphQL library to run on. I mean, they exist for Python and things like that, but it's a GraphQL query. It is an HTTPS query, but you don't want to really interpret that result yourself using curl, which, with regular web services, you can do the effect of curl inside of your application and sort of work. So.
What are the ugly, crusty edges that you haven't mentioned?
Once you understand all the pieces that go into it, and so AWS doesn't do a good job of explaining how all of these things go together until you start actually doing it. That's why I tried to explain all the different pieces to you. After that, the only really crusty edge is a velocity template language, which, I mean, it's a full-blown language, but it does look kind of weird. If you've done velocity before, you'll be fine with that. If you're not doing something that's, really edge case, you'll probably be fine with the examples. But I'm not an expert in velocity, so I mean, if you asked me to write a very complex function in velocity, it would take me a while. And it is a template language, so it's mixed in with your JSON. It looks a little strange. This has been out for quite a while. CloudFormation is pretty complete for this. So is the Terraform implementation. But once again, I only use the provisioner for endpoints and data sources. I use a CI/CD model to get that fast turnaround for the schemas, functions, and resolvers. And that's nice for DevOps too. I mean, from DevOps perspective, you provide the endpoint, you provide the data sources, which you control, and you let the development team write their own interface. I mean, what do you care? So, other questions? Everything we've done with AppSync has been ridiculously fast compared to standard web services. So we've seen performance increases, frankly, over writing like a CRUD service or our own stuff. I don't know what they do under the covers, but it's pretty quick. Like, it feels almost instantaneous from a user experience. Obviously it's not, but yeah, it's very fast. So under the covers, AppSync uses API Gateway, and I think they push it to the edge, although they don't really say. It feels like they do when you run it. Obviously, if your database is in US East and you're hitting the edge in California, there's going to be a little bit more lag. But the edge stuff, the edge API Gateway stuff in AWS actually, what it does is it drops you onto the closest endpoint or entry point into the AWS network. And after that point in time, you're not traversing the internet any longer. You're traversing the private AWS fiber that they run between their regions. So I think they publish, there's like speeds of 50 gigabits between regions right now. So it's super, super fast to do it that way, which is probably why we saw performance increases. Other questions? Okay, sweet.